Yes, sir. Okay, we are rolling. Hello, friends. Hello, everybody. Thank you very much for tuning in. Really glad you could join us. Whatever platform you are on, whether it's SoundCloud, YouTube, iTunes. Thanks for listening. Thanks for watching. And today I have a very special guest with me. This gentleman is somebody whose work and writings I've been following for many years now, and he's had a profound influence on my knowledge of, let's say, the brain and benefits of exercise to the brain and the neuroplasticity of the brain. And this has all led to me changing how I train people, especially anyone, but especially in the Parkinson's population that I work with. He is the author of several best-selling books. One of them I do not have with me because I gave to a friend, but I have the audio of all and the hard copy of 3 of them. But User's Guide to the Brain is one of them. It's an amazing book. And many people who I talk with have heard of Spark, another groundbreaking book, in my opinion. And of course, we have Go Wild. We'll touch on some information from here today, as well as Spark. And then I got this one a long time ago, co-author of Driven to Distraction, which describes me perfectly. He is also an associate clinical professor of psychiatry at the Harvard Medical School. It is my great pleasure to introduce my guest, Dr. John Ratey. Thank you, sir, for joining me again. How are you today?
I'm fine. Thanks for having me again. Delighted to talk.
Yeah, I just got to put it out there because it was my fault. I found out the last one we did, the file got corrupted. That won't happen this time. So okay. You're a very generous man to join me again, and you know, thank you. I wanted to start off with a subject that really turned my head years ago, a few years after I got into the personal training and the fitness business. The benefits of exercise for the brain are monumental, or even just walking, which we talked about last time, how the brain lights up and all kinds of things are happening. This has really changed how I look at things and how I work with people. Let's start with what's happening with the brain how are we optimizing the brain via exercise?
Okay, well, I think people have to think of the brain like a muscle. The more you use it, the better it gets, the stronger it gets, the more developed it gets, the more resilient it gets. Just like exercising your quads or your biceps, triceps, whatever, it's the same principle. And so when you're using your brain likes it, and it has a lot of good science behind that. We say use it or lose it when we're thinking of the nerves and the nerve cells and the brain cells and all that go into our understanding of the brain. And so when we're exercising and we are using more brain cells than in any other human activity, more brain cells are being used when we move, and exercise is a lot of movement, right? Different kinds of movement, different parts of the brain are activated. But nevertheless, most of the time when we're moving, yoga, walking, running, lifting, swimming, biking, all those demand a lot of our brain to do it, and to do it correctly or incorrectly. And because there's so much of our brain evolved to help us be the best movers. And what we know, evolutionarily speaking, when we were hunter-gatherers, we were moving about anywhere from 10 to 14 miles a day on average, foraging, climbing, lifting, running, sprinting sometimes for food or to avoid being killed by tigers and bears and other people. Sure. So we were movers, and our brain evolved during this 6 to 8 million years to help us be the best movers possible.
We were
develop
designed
more
to
brain.
move.
Yeah, we're designed to move, and we're designed to move well. And with that, we develop plans, prediction, sequencing, memory, short-term memory, long-term memory of what plan worked the best, how to do it, how to do things automatically. All those things developed during this time to be the best movers. And then when we increased our group that we had and increased our language, that part of the brain that we use to help guide our movements and plan for them, we use to think with. So that really a great phrase is that our thinking brain is the evolutionary internalization of our moving brain. So when we move, we activate our thinking brain. And we do all this stuff, and it makes, now we've unpacked it pretty, every day we're unpacking it more and more, but about how the brain works. But what we're learning is that when we move, we have a tremendous effect on all kinds of things. And the latest, by the way, relevant to COVID, is that there's another antioxidant that we make when we move our muscles. It's called ECOS,
yes.
extracellular whatever. Anyway, it's in this cellular space. We make it with when we move our muscles. And this works preferentially in our lungs to prevent lung problems. And now we don't know about COVID specifically, but it stands to reason if it's helping prevent other lung problems, it might have an effect on interrupting the binding of COVID in our pulmonary tree. So that study out of the University of Virginia just 2 weeks ago, by the way, 2 weeks ago,
right,
showed this, that exercise really increases our this particular antioxidant, and it's really quite stunning. So it does a lot of those kinds of things. It increases all these growth factors in the brain to help our brains grow. The one that is the mother of all growth factors is called BDNF, or brain-derived neurotrophic factors, which is the growth promoter. It's been called the brain fertilizer. I called it miracle grow for the brain when I learned about it. And it gives people the idea that if you have more of this stuff around, your brain's going to be healthy and grow.
It's amazing. You talk a lot about that, well, in all of your books, but especially Spark is where I first learned about it. The whole thing with the Naperville, Coach Lawler, Naperville School District, and the benefits of retention and attention and grade GPAs were higher, obesity was very low. So that was my first introduction. It's amazing what that can help us with, exercise, but also BDNF.
Yeah, no, it's, we discovered it really in the 80s, BDNF. The fact was it was looked at as something that helped guide our brain's evolution within ourselves. As an infant to an adult, BDNF guided our brain cell development. Well, also we learned a lot about how it prevented aging, the aging brain, the prevented the ravages of time and stress over time, to help prevent the erosion and the lack of it, of our brains doing what they're supposed to do. Your area of interest with Parkinson's, huge issue in BDNF, is a good way to prevent it and to treat it, if you will. More BDNF in the dopamine area of the that you're focused on will help regrow those brain cells and their receptors, so that you have a better communication within that area of the brain, and it is called the mother of all growth factors, but there are many others that come from the brain itself, but also come up from the body, and it comes up from our muscles and our heart, that come up to our brain to help guide the brain to work optimally.
What is the difference between BDNF and GDNF?
GDNF is more of a general glial. It's a glial growth factors. There's twice as many glial cells in our brain than there are nerve cells. But BDNF is much more about the brain cells per se. But both of them are important, and both of them are involved in general brain health. And the more we exercise, the more we activate our brain cells, which we now know is the way we make BDNF. And for instance, a way to think about it conceptually is when you fire a brain cell, you release this BDNF. It sort of helps the brain cell grow, which is its job. But then we have a feedback loop once you release it, that sends back information to the brain cell that released the BDNF to turn the genes on to make more BDNF.
Oh.
So it's what I call evolution's gift to us, saying, if you need it, it will come. You know, if you build it, it will come from that movie. You know,
with Kevin Costner, Field of Dreams.
Yeah. And it's like, okay, if you're using it, we're going to help you and support you. And what's important for people to remember or to know is that the way we learn anything is for our brain cells to grow. And that's important, so that the way we learn any fact, figures, as well as movements, as well as yoga poses or kickboxing, those are, we learn that by growing the nerve cells to make better connections.
Sure. So does this, let's say, here's an example. Oftentimes in my workouts with clients, I call it either layering or stacking. Lately, I seem to use the word stacking. So let's just say we're doing a focused movement. For example, I have a few clients who can jump on one leg sideways through one of those agility ladders, right? And so what we do is during this, first of all, they have balance, center of gravity they're dealing with. We'll throw in cognitive exercise, if you will, something like, well, it's election year. So we usually have fun with presidents on election year, like name every president starting now and going backwards. Okay, start with the current, spell his last name, spell it backwards. Or, you know, maybe it's name the capital of Texas, Austin, spell it forwards. Great, spell it backwards. This is while they're moving. And then throw in a hand-eye coordination just for fun. Maybe I move around too to get the head turning, eyes tracking, a little vestibular activation. So does this type of thing help the brain, considering we have a focused movement, a hand-eye, and we're thinking about something? Does that help to create, let's say, my goal, I have to back up. My goal is to take this and other things we do like this, there are countless things we come up with, improve multitasking abilities so that when they get outside of the facility, they function better, and we reduce fall risk. And what I hope is happening is that developing and doing this over and over again with different types of activities might cause new neural firing pathways.
That's exactly it's exactly what happens, by the way. I usually start off my lecture when I'm talking about the aging brain. The antidote to aging is the continual challenge of the brain. You're challenging the brain in every which way with what you presented. You know, okay, we jump on one foot, so there's balance and coordination. To the left, to the right, spell, then you have to think while they're moving, maybe, and then you moving around to make a moving target. So all that requires much more brain involvement than even certainly than just walking on a treadmill or running on a treadmill, but which is great, you know, by the way, you know, it's fantastic, but it's one kind of movement. And so what you get with what you're doing is all kinds of stress on our nerve cells, which, you know, people have such a bad view of stress. And in the second chapter of Spark, I fell in love with stress again. You know, I wrote in a user's guide I wrote 10 years earlier, but the Spark, you know, the second chapter is all about stress, and it's a reconfiguration of stress in my own mind. Couldn't believe it in 10 years. Oh, yes.
Okay, there we go.
3. There you go.
Stress, the greatest challenge, yes.
Yeah.
Well, there is good stress and bad stress, so I would assume this
absolutely.
Is good stress, yeah.
Most people, when they think of stress, it's toxic stress. It's stress that doesn't go away. The kind of stress that's important for learning, for moving, for exercising, it causes stress on the muscles, on the blood flow, on your brain, and you get what's called recovery and repair set up to deal with the stresses. Well, this happens locally in your muscles when we're moving, but also throughout the body and then throughout the brain. And then when we have periods of rest or recovery, then we have growth. And if you don't stress, you don't grow. And that's the danger, by the way, of us in COVID, not stressing ourselves. Right. It's easy to sit and watch Netflix and other kinds of thing, or stay up with the latest numbers on COVID, the latest political problem, whatever. But the more we stress ourselves, that is, push ourselves to be involved in other things, to exercise, to jump around, to move while you're Zooming, you know, that's going to, I'm sure may have a op-ed coming out on that, doing Zoom while you're moving, because it's, you know, where it's possible. If you're in a Zoom meeting and there are 12 of you, that may be easier to do than it is something like this. So
sure. Well, it's interesting. So the feedback I get from people, you know, I've traveled a lot too and taught in all over the world, but we teach concepts, which, you know, I have to thank you as one of my very, very, very primary influences as far as conceptually what's going on, and taking that and being creative with it. You know, safety first. People can do what they can do, and we want to push them and challenge them. We don't want to hurt them, but we don't want to be, if they can move around single leg on a ladder, we don't want to have them sitting in a chair exercising all the time. So let's get the body moving, do what we can, push a little bit. You know, it might be just they're walking, maybe it's slowly, but they're thinking and walking and out loud, spelling things, math equations, whatever, playing catch. So we do what we can, not what we can't. However, reports and feedback I like, because we're finding that people are finding that, for example, if they almost fall 20 times in a workout or in a workshop, and they do this on a regular basis, then when they get into real life and they almost fall, they don't fall. They're able to recover. For fall recovery, things kick in faster. People call it muscle memory. I think it might be more like brain firing patterns that are firing faster that cause your muscles to, through your nervous systems, to activate and save you. And I love it. I'm actually doing it myself because, I'm 59. I don't really want to be falling down in 10 years, 20 years. And plus, my balance isn't as good as it was 3 years ago because I was on airplanes all the time. So I'm really liking the effects that I'm seeing overall. And I have to thank you for much of what I've learned.
Well, yeah, no, the whole business of preparing for the future is really what exercise is about. I mean, it's fascinating. One of our major chapters in this new book, on our fourth book on ADHD, that is coming out next year, maybe. I mean, it will be done, but whether they release it in the midst of COVID, who knows?
Yeah.
It's like, who cares about anything except COVID? Survival.
Yeah.
But anyway, but one of the big chapters is on the cerebellum. The little brain in the back of our head, where we have, it's a third the size of our brain, but it packs 60% of all of our nerve cells, and it's constantly clicking away, constantly evaluating and stabilizing us. It makes our motor system really more fluid, more less choppy, more continuous. Well, it does the same thing to our brain, to our higher brain functions, not just movement, not just our body, but to our attention, to our thinking, to our emotions, even, so that we know that by training the cerebellum, vestibular, all that goes into balance and coordination. What you're talking about, falling, it's all about training the cerebellum. And the good news is that the cerebellum is very trainable because there's so much activity. It's what we call higher in the percentage of neuroplasticity.
Okay.
It is easier for it to grow and change. And so we just by practicing, you really develop things fairly quickly. I never forget, when I was writing Spark, I had a personal trainer. I called he was Russian trainer for the Russian Olympic jiu-jitsu team. Okay. And he was over here, obviously, and a trainer, and I had him 4 days a week. I had him for about 6 months, and he, I was really into it, and really in great shape. And he said, okay, one day he said, stand on the Bosu. We hadn't done any balance.
Mm-hmm.
And so I got up on there, and it wasn't great, but I could do it for 20 count. And then he said, okay, close your eyes. Fell off. Couldn't do it. And I couldn't believe it. I thought I was a tennis player, and I had balance, blah, blah, so forth. So we worked on balance. So in 6 months' time, along with everything else, I was able to be on the Bosu, do a squat, eyes closed, jump 90 degrees, and with another squat, eyes closed the whole time, all the way around.
Oh, wow.
6 months. And and so my balance and coordination skyrocketed, obviously, just by that. Then I went away for a year and a half, more or less, didn't work on the balance at all, really. traveling about, and came back, and I still had much better balance, but not nearly what I had before.
Mhm.
But just a few weeks of retraining got it back. And so you lay down the scaffolding, like you're talking about, stacking. You lay down the basic stuff, and then work on the fine stuff afterwards. So,
well, that reminds me of an analogy that I use a lot in workshops, and that's when we talk about neuroplasticity, new neural firing patterns, riding a bicycle. And I think we talked about this last time. So right in my front yard here, back in the 90s, both of my children, within about 90 minutes, maybe 2 hours max, they went from never riding to riding by themselves. No training wheels, no nothing. And I'm thinking, then I had no clue. Now I'm thinking, so that's how fast the brain actually developed these connections. And so then you do it and do it and do it more and more and more and more and more for months, years, whatever, and you're solidifying the connections, I imagine. Then you take a break, but the old phrase is just like riding a bicycle. So am I right in saying that when you get back on after some time off, you might be rusty, but you don't need to relearn? You just need to fire them up again. Is that what happens?
That's what happens. You have that stored, and that's where muscle memory is a mistake. It partly is your muscles do remember, but it really comes from the cerebellum. Automatic behaviors are all about cerebellum, and that's what happens when you. And I like to think of Michael Jordan. When he was playing basketball, he wasn't thinking about it. He was just moving.
Yeah.
It was all automatic. It was all lower than the frontal cortex. Although people that are in that kind of zone all the time really sort of they observe themselves. And that's the most pleasant experience of when we're in the zone, of knowing that you're in the zone and seeing how you're doing. Also, you're ready with all those usually involved neuroprocessors to help correct. So something novel that comes in to your field, you'll be able to deal with because you're already on automatic pilot, but you also are ready for something novel. So you switch.
So interesting. Since we spoke last time, when I ride my bicycle, which is most days, I like to go through the woods, the trails, and I'm looking at it differently because I'm thinking of, how many trees I have to avoid? So there's an interaction going on, and it is constant. And I can't even imagine if you were able to monitor the activity, there must be a lot, especially when we're avoiding crashing, 500 times over a few miles in the woods.
Yeah.
So that has to be good. That has to be good for us.
Yeah, no, it's all that automatic calculation that you have no idea you're doing. Yeah. It's not like, I'm gotta think about it. Unless you're just starting again or whatever, then you have to retrain. You just have to be much more alert. But then after a while, it becomes, you get back into the flow again.
I did have an encounter with one tree, but I'm still here. The tree won. So it sounds, if we go dial it way back right to the beginning, here I am, I'm sitting, right? But I can decide to turn on the switch. All I have to do is get up and move, right? So that's where, as a trainer who here, well, with my clientele, they're pretty dedicated, but before I worked with people with Parkinson's and movement disorders, I was doing more, they weren't weight loss. There's nothing wrong with it. It's fantastic. If people need to redistribute the weight in their body and lose some weight, that's fine. But the level of commitment was different. It wasn't like they couldn't walk or they were falling a lot. I found that the compliancy was less, and I heard a lot of excuses. But we can decide to move and turn on the on switch of the brain and do our bodies some good.
Yeah, and that's a big thing. The University of Michigan has spent 20 years looking at motivation and exercise, how to maintain that motivation. And the easy answer to that is for people to recognize how they feel after they've exercised. In other words, don't look at it as a weight loss thing or as developing skills necessarily, but look at it how you feel today after you've had your walk or your run or your swim or your bike, or your push-ups and whatnot. How you feel, what's different, because you will have activated your brain in a very massive way if you exercise a lot, because you change your brain chemistry, not just with BDNF, but you change norepinephrine, dopamine, serotonin, GABA, oxytocin, all the good chemicals that we have circulating in our brain that are growth promoting. And the more we do it, the more stuff we liberate. We change our concentration of these neurotransmitters. And I say taking a bout of exercise is like taking a bit of Prozac and a little bit of Ritalin. Because we do the same thing when we exercise, when we move, when we walk. You don't have to be even running. When you walk, you're doing this. Now, the more you exercise, obviously, the bigger the concentration. You're gonna activate more and more brain cells for a longer period of time. You're gonna, just as you find with your Parkinson's patients, especially. It's a lot of it is about dopamine, right? And you want to increase the dopamine that's they're being released because they're deficient in that. It's sort of the definition of Parkinson's. So the more you challenge those brain cells to act, the more you're going to set up a feedback loop to make more dopamine presynaptically, as well as making more dopamine receptors postsynaptically, which is really the way you knit together the success of the nervous, we call a cellular assembly, and that then leads to smoother movement, initiating when you want to,
right,
stopping at the right time, all that people with Parkinson's have a hard time with.
Now, dopamine is a reward type of thing too. I know. Actually, I'm discovering some things about myself the past couple of years that I think I might be a dopamine addict, because typically it's not, and not to talk about me, but it is an example. It's a real life experience. It's not uncommon for decades now for me to wake up feeling kind of sad. It used to shut me down. I would go into days of not really doing anything and being very unproductive. However, I know now, and what you said is so important about how you feel after you exercise, or maybe even during it. There are a bunch of things I figured out. First of all, if I just get started, my 3 words I use with everybody, I get the energy to keep going. And within 2, 3, 4, 5 minutes, 10 minutes on a bad day, I'm already feeling better. And when I'm done, I forgot I even felt sad in the beginning of when I first got out of bed. So it's like nature's natural antidepressant. And
Yes.
I get energy from it, and I sleep better, and all the other good stuff. And I'm writing a book. I'm almost done, for real. But I was almost done 2 weeks ago too. But I'll exercise before writing because I write better after I exercise.
Right, and that's over the course of anything you're doing, especially cognitively and emotionally. A bout of exercise is not only wakes you up, there you get more aroused when you're getting out of your bed, but you turn on, again, you've taken a little bit of Prozac or Zoloft or whatever the current favorite is.
Yeah.
you've taken an SSRI, you've taken a hit of a stimulant, just with your exercise. So you're more focused, you're more motivated. And by the way, a big thing that is really important, especially in our situation here with COVID, you are more loving and more lovable after you've exercised, because you've changed the chemistry. But one of the big things you've also done is elevated the concentration of oxytocin in your brain. And oxytocin is the bonding hormone and the love hormone. And in our COVID life from here on, that is so important, and it's going to become more important for us, is to be more loving and to actually be more lovable, so you get more connections. And
So interesting. So you have been so generous with your time. I do have a couple more things real quick. We don't have to go much longer, but there is, first of all, that's fascinating. And I'd like to be more lovable, so I'm going to exercise more. So my latest work.
When I lecture at a boys' school, at primary school or secondary school, and the boys are there, they're hearing this, and I talk about raising levels of the endorphins and the endocannabinoids. So it's like making your own marijuana and making your own morphine. And then, but when I talk about making your own oxytocin and it makes you more lovable, the boys go, "Oh my God," that they could get.
Yeah, sure. I probably would have been like that back then. Yeah.
No, but I mean, it just the response is very predictable, but they really love it.
That's great, man. That's so funny. That's great. That's interesting. So going back, there's a couple more things. You mentioned last time, and you mentioned it a lot, and we really go into detail in this about the benefits of. We just talked about benefits of exercise, okay, and moving, but outdoors, barefoot, and with another person.
Yeah,
it's like the trifecta plus exercise. Could you just elaborate on that just a little bit?
Well, I think the more natural we get, there's, first of all, outside. Outside is so important, just as you're avoiding trees, okay? When you're riding, or not so much, but when you do avoid the trees, so it's not the same as the protected environment of the gym. Plus, you're outside, which has its own benefits. Not only vitamin D, which is so important, especially COVID. I mean, there are papers, almost weekly papers, talking about the benefits of vitamin D vis-a-vis COVID, okay, in terms of the, how morbid, how disastrous it can be. And the more you pump yourself full of vitamin D, and the better you're going to be to avoid getting it in the first place, and also the ravages of it. And one of the great ways of getting vitamin D is being outside. Sure. And as we're coming into spring and summer, where being outside is going to be easier, and you get the sunlight, and that makes for vitamin D naturally. But also, that's just one small part of the benefit you get from being outside, because we are drawn to being outside. We are drawn to nature. There's something called biophilia that was one of my colleagues at Harvard many years ago talked about this as we're drawn to nature. We love it. Biophilia, we love nature. We do. We feel better. All these studies have come out. And now we have people that are experts in what the Japanese call forest bathing, getting people out into nature, because it does so many good things in terms of lowering stress, lowering blood pressure, lowering insulin needs, all that, from just being outside, just living and being around trees and plants and animals, and just as you're doing in your forest there. It's a big element. Then you add another person. Oh my God. Think about how important that is, not only for enjoyment and for accountability, which is a big thing when you're exercising together.
Sure.
But also it's a huge complication. It is a lot more stress in a way to be with another person, because especially if you're doing something in tandem or interactively.
Sure.
You know, you want to make sure, you want to blah, blah, and paying attention to body and movement and what they're doing. And especially if you think of dance, wow, huge,
Right. Yep.
huge taxing the brain. I mean, if you get your guys or gals, the Parkinson's group, to dance, holy mackerel, that's, movement, balance, coordination, and the other person, and getting the right, and listening to the music, and moving their body in relation to that, doing the salsa. Oh, huge. I mean, one of the things that we do, my wife and I do, is since we've been here, is Zumba. We have we've been doing a Zumba class 3 days a week. With a friend of ours from Bali, actually, but it's a Zumba group, and it's fun. And I'm not coordinated that way at all. So it's talk about a challenge. It's great though, because
so your brain's firing up on overtime.
Oh yeah. But I'm learning. I learn stuff.
Yeah.
I can eventually I can do a decent move without looking like a spaz. But it takes a while. And then after you get it automatic, then it's fun. You see.
Yeah.
Then it's fun.
Exactly. It's funny because in our workshops, I started off alone doing them. I created this program, traveled, taught, but then I added more material, so it went from 1 days to 2. And I needed help, and also figured nobody wants to listen to me talk for 2 days, so I hired friends of mine. Actually, Russ Parker is a gentleman who lives in Huntington, Long Island. He lives with Parkinson's. He's in his early 60s. He's also a trainer, a great trainer. So he's become a part of our instructor team. He and his wife have been doing ballroom dancing for years. And he runs the dance, many portions of our workshops, but he does the dance.
Yep.
And then Ruben, who lives in Costa Rica, is also on our team. And Allison is another one. We have 4 of us. She lives in Massachusetts. But Ruben will do the salsa because he's in Costa Rica, and that's what they do there. So when we get Russ and Ruben together, sometimes they teach without me. They'll be doing ballroom dancing, all kinds of line dancing, salsa dancing, and you know what? People love it, but they're also thinking during this too. So we have a cognitive development because they need to think about the next move until they automatically can do it without thinking. It's very fun, very fun.
Yeah, and that's an element too that needs to be in the prescription for exercise. The fun aspect of it, that'll keep you coming back.
Yes.
That'll look, like, and that's what Zumba is. Now it's like, oh, Zumba, 5 o'clock. Okay, let's go. And we got to roll the carpet back and get ready. Zoom in.
It's good, I'm glad you said that, because for those who are watching and listening, one thing I find as a trainer is client compliancy is much higher when people do things they like to do.
Oh yeah.
Now we can't just do only what they like to do. Let's experiment. And sometimes we'll find things new to them that challenge them, but they enjoy it. So we're always looking for things, and they absolutely hate something, we're not going to do it. But that'll keep them coming back, like you said. And that's what we need. That's what we want. Hey, I have one more question, just one more. Although I did want to ask, I have 2 real quick. You kind of covered this, but it seems that is the cerebellum does that have the ability to not only, be highly neuroplastic, but can it grow new brain cells, like additional brain cells?
Yeah, no, not the cerebellum, not that we know of, not the cerebellum per se,
Okay.
but certainly the big area that grows new brain cells is the hippocampus,
Okay.
and that's sort of the queen or king of neuroplasticity.
Okay.
Is you make more brain cells, but it often gets overemphasized when people are talking about exercise, that we make new brain cells and that's where we get more neuroplastic. And in fact, what we're talking about is making more connections for
Connections.
neuroplasticity.
Okay.
And then also we make new brain cells, something called neurogenesis, that we discovered that humans do this in 1999. So it's relatively new concept. And it took a long time for most people to agree to it.
Mhm.
And most neuroscientists, most neuroscientists don't change their mind; they just die. I mean, that's the phrase. It was really scientists, but it could be anybody. But they, for so many years they were steadfast against new nerve cells, and then boom, this whole. And actually, in Parkinson's, that was a big area of trying to create new brain cells. But anyway, we do in our hippocampus, which makes the most sense because the hippocampus, really, you can think of it doing a lot of things, but it's sort of central station for memory.
Mhm.
Okay, and so when we're learning something new, it goes through the hippocampus. We have to activate that as a way station to the rest of the brain. But it also is a center point for stress and anxiety.
Oh.
So making new brain cells there make a lot of sense.
Mhm.
And the people at Princeton have done work showing in the past 5 years that the kind of new brain cells we make in the hippocampus are over proportionately using GABA.
Okay.
We make more GABA cells, and GABA is the brain's brake. So putting the more inhibition nerve cells around helps us not over respond to a threat from the environment or internally when we're getting anxious or we're worried about something. So the more GABA we have, the more brakes we have to put on.
Okay.
And so we make more of these brain cells than in this area of the brain to help us improve our memory.
Mhm.
And there was a big argument, and still there, is that when we learn something new, do we always have to make a new brain cell? No, but it's sexy, and people like that. And the reason why it's so important with exercise is that there's nothing that we know of, no drug, no even what we can do genetically at this point, nothing that makes more new brain cells than exercise in the hippocampus. And there may be some in the frontal cortex as well, but we don't know that they haven't seen new brain cells in the cerebellum as of yet, but that's all to be, futuristic. We'll know more.
Interesting. So it sounds like, in fact, my son is the one who told me this. His PhD had to do with research in Parkinson's years ago. He was telling me how the substantia nigra basically outsources to the cerebellum, sort of.
Yes.
And the cerebellum picks up the slack because it already does a little movement anyway. So, but also because of the neuroplasticity level in that area, which it just makes a lot of sense. Very interesting. We know the barefoot training is good. Barefoot. I don't want to take up much of your time. But in Go Wild. So for those who are listening, I'm holding up a book called Go Wild. I remember where I was when I heard. Oh, we know Casey Stutzman too.
Oh yeah.
So I was running hill sprints at the park a couple miles away, and I was like, he knows Casey. That's cool. But I was also had listened the same day to benefits of barefoot stimulation, which I find to be also very interesting because the way it just can wake up a lot of those dormant nerve endings in the plantar fascia and or plantar skin, and then boom, send the message to the brain. And I'll tell you, that's really helped. Our workouts are all barefoot. That's how.
Oh, good,
Yeah,
good,
all
yeah.
always. Unless they have some kind of an open sore or something, we get them barefoot. Um, the last thing I wanted to ask, and you're welcome to talk for as long as you want. I have no schedule today, but you mentioned three things last time: optimal weight, continue learning, and exercise as like the trifecta for living probably a improved quality of life.
Right, right. Yeah, that's from a study that started the whole. When I talk about the spark, the revolutionary new science of exercise in the brain, that tipped it off. There was a big study, a MacArthur study, and about looking at 12,000 people in a bunch of different countries over a period of 6 or 7 years, looking at what were the habits that help prevent the onset of cognitive decline and Alzheimer's disease. And this is in the end of the 80s. And there were three that you mentioned: optimal weight, continuous learning, and exercise. And then we knew about the first two. Okay, we knew that this was important for preventing cognitive decline. I mean, continuous learning. There were all these studies that showed that, if you continue to learn throughout life, you're going to basically have more nerve cells to lose. Mm-hmm. So, you're going to prevent that if you learn continuously. And optimal weight, the ravages of diabetes type 2 and just having too much fat tissue on board, it increases your chronic inflammation and reduces your inflammatory ability. Your immune response is not as great. And that has come into focus even more now with COVID.
Sure.
My God, when people who are on the ICU tend to be overweight or obese. And that can be a ticket to the ventilators, which can be a ticket to death. And so it's even more important these days to be near your playing weight or optimal weight. However, what we didn't know about was exercise. So one of the originators of this whole field, Carl Kottman at the University of California, Irvine, went back and said, I'm going to find out why exercise is so important. And he started working with mice and running wheels, et cetera, and found out that if they got them to run, and they loved to run when they learned, they were about 40% smarter after 7 to 10 days. Looked at their brains. They were much more connected in the cortex. Their brains were heavier than the controls. And they looked at the BDNF, and that was 2 to 3 times what it was at the beginning. So this led to this revolution. Everybody wanted to know about exercise because, oh my God, not only diet, but also, and learning, but also exercise. Physical exercise could have a powerful effect on the brain, and that tipped the balance. And then it led to all the stuff that I have in Spark.
Well, it's really interesting. You mentioned, I believe it's in this book, because in the book I'm writing, I pulled right from this and used to put a citation in. Had to do with, I forget how many, 40 Japanese businessmen walking in the woods.
Yep.
And was it their immune systems were boosted after an hour, or but there was something with 30 days later too, something was boosted. And I don't remember if it was immune system or IQ or both.
Well, I think not IQ, but their ability to learn perhaps was continued to be better. But yeah, the chronic inflammatory cytokines were less, you know, and which is a measure of your immune response. So your immune system was better
That's
after.
after just one walk?
Well, it's usually, I think they were probably there for a day, you know,
Oh,
but
okay, yeah.
yeah,
But
yeah.
there was a
But
carryover effect that lasted quite a
oh
while.
yeah, oh yeah, oh yeah, yeah,
Okay.
yeah. You know, I'm going to have to cut off, my friend.
Yes, absolutely, absolutely. Listen, I want to thank you very, very much for joining me again. Uh, it's been a real pleasure, Dr.
Yeah.
Ratey. I appreciate this, and thank you everyone who is watching and listening. I hope you have a great day. And if you don't mind for 30 seconds, if you could hang on with me, I'll end the recording. But thank you everybody for watching and listening, and I hope you enjoyed it. I learned a lot again. Have a great one.